simulation has many strengths, as shown here. And the earlier in a system's design and lifetime it is used, the more valuable these strengths can be to you. A simulation model permits not only finding problems and deficiencies, but also evaluating proposed improvements and solutions without shutting down, disrupting, or destroying the real system. Simulation models can imitate real-world variability, arrival rates, service times, downtime occurrences, allowing accurate assessment of their effects. The simulation user benefits from animation. Simulation is like a movie, not a snapshot, and comprehensive reporting of performance metrics. These metrics include percentage utilization, average and maximum queue lengths, and jobs completed or people served per hour. And all of these metrics are conveniently exportable to heavy-duty statistics software. Now, the 5 bullets on this slide all derive from various projects I've been involved with over the last 35 years. They illustrate the versatility and broad applicability of simulation. All of these simulation models contain entities needing services, whether the entity be a crate to be transported to the loading dock, a patient with a bone that might be broken, a ship waiting to steam into a harbor, a truckload of beer to be delivered to a supermarket, or a prescription urgently needed at a patient's bedside. These entities are created, travel through the system, that's a computer model, and are disposed when completely served. So watch for the words create and dispose when we demonstrate ARENA. And the simulation model gathers KPIs, that's key performance indicators, on how promptly and completely they are serviced. Now, reaping the benefits of simulation requires investment in both money and learning. A software package, ARENA's the one demonstrated today, is necessary. The newer simulation user may either buy a package or hire a client who has multiple packages to use. You've already begun the second item by attending this webinar to learn what simulation can do. Basic awareness of simulation technology begins with the realization that simulation results quality is the smaller of, or minimum, of data quality and model quality. The results of a simulation project are no stronger than the weakest link. A key statistical issue involved is that of interdependence. A model will demonstrate very quickly that if, for example, operations in series all have reliability 90%, the overall reliability is much less than 90%. Variability is another key issue. If, for example, the average queue length of waiting parts fits in the buffer, that's no guarantee the maximum queue length will fit in the buffer. Therefore, the simulation needs accurate data. No model can produce results more accurate than its data. One of the advantages of ARENA is that it includes a distribution fitter, a piece of software that examines input data sets to determine what statistical distribution, it might be Weibull, log normal, Poisson, gamma, etc., best determines their pattern of variability. Now, processes, the first key ARENA concept, they're represented by a process block in ARENA. For convenience in interpreting output, A process may be classified as value-added, non-value-added, transfer, weight, or miscellaneous. Entities move through the model. As mentioned, an entity represents whatever the modeler desires. An appliance being manufactured, a truckload being delivered, a patient being diagnosed and treated, an airport landing at, taxiing in, discharging, and then boarding other passengers and taking off again from an airport, or a guest checking into or out of a hotel. Entities can have attributes which affect their processing. For example, what illness does the patient entity have? What is the passenger capacity of the airplane entity? Is the truckload of soft drinks being delivered in cans or bottles? These entities arrive to the model at create blocks and leave the model at dispose blocks. Resources are seized and released, for example, at a process. Entities need, use, and monopolize resources. A resource might represent a runway at an airport, an MRI machine at a hospital, a machine in a factory, or a dock at a warehouse. The availability of resources can be controlled through shifts. Entities can define their priority by using different values for one of these attributes. For example, the broken foot likely has higher priority than the severe sore throat, and the heart attack, in turn, has higher priority than the broken foot. In a warehouse, some orders may be rush orders. At the airport, an incoming flight with many close connection passengers, or a passenger who's taken ill aboard, may well be granted higher priority. In more advanced use of ARENA, path networks may be defined for use by equipment such as forklifts, tug trains, orderlies carrying litters or pushing wheelchairs, or AGVs. That's our nickname for automatic guided vehicles. And as the model is built, an animation is automatically built right alongside it. So now I'm going to set PowerPoint aside for the moment and minimize it. And here is ARENA. We'll do a little demo of it. ARENA version 14.70. That's what we're demonstrating now. So we've opened it. There's powerful toolbars up here along the menu, and at the left, here's the basic process template. ARENA has other templates. Now here's a glimpse of the advanced process template. You may or may not need this. You'll always need the basic process template. And the advanced transfer template, that covers details of material handling using things like conveyors, automatic guided vehicles, and so forth. Now, back in the basic process template, I'll drag a create. I'm dragging a process, and they hook together automatically, but I can override that, and a dispose block into the model. Other connections can be added whenever needed using the Connect tool. It's right up there. We see that the model window has two regions. Here's the flowchart view up above and the spreadsheet view below. Now, under the window menu, there's a toggle. I can make this go away or come back. I can resize, but usually I just leave them both open. And when visible, a spreadsheet view will show details of the most recently added or selected model block. Well, I added the dispose most recently. Now I'm going to double-click on the Create block. That lets us edit it. Now I can provide an appropriate name, and the inter-arrival time. For the moment, we'll just leave it. Inter-arrivals occur an average of, let us say, 15 minutes apart. We have to be careful of our units, exponentially distributed, and the patients arrive singly, and they'll keep arriving until the model comes to an end. We tell the model anytime we want how long it should run, with creation beginning at time 0. And I'll click OK, and now I'll double-click the process block. Maybe the patients, these are the ones needing an X-ray. So I'll call it that, and we'll assume that taking the X-ray is triangularly distributed with a minimum of 5 minutes and a maximum of 17 minutes and a most common time of 10 minutes. And yes, minutes, we have to watch our units. And all of this we get summarized in the spreadsheet view below. And we need to seize a resource, which I'll call like an X-ray machine, at this block. So instead of just delaying, we're going to seize a resource, delay for a time while we use it, and then release the resource. So I click that, and I'll add the resource named X-ray machine. There's only one of it. Now that would be interesting. Maybe, oh, what if we bought a second one? You'd put a number 2 in there. That's a nice quick way to see, well, how much would it improve matters if we did make the significant capital investment of a second X-ray machine. And we'll click OK, and at the dispose block, double-click to edit it. I'll just call it exit, and yes, we want to be sure to record the entity statistics. Now, about the X-ray machine resource, I actually created it automatically. And I dare say you have already noticed that this basic process template has yellow things up here. They represent arena blocks or flowchart modules. And these little lined ones are called data modules. And we'll click on the resource one. Well, I already defined it conveniently in the X-ray machine. It has a fixed capacity. We could define a schedule. I mentioned that in the slides. And so that's defined for us automatically. We could define schedules when the workers were on shift to run it. And let's define a failure. The X-ray machine may have breakdowns, if only because we need to put more film in. So we'll click a failure, double-click there, and we could call that failure anything we wanted, which I'll leave aside for now. And we have to wait during the failure. And now we have a failure defined. So there's one row. Well, what about these failures? In more advanced work, oh, there's the next template. You click on the failure. We already defined it. We'd give it a good name like replace film. And we would say, this might be a good one here. Well, after every 100 exposures, we have to replace the film, and the downtime takes, let us say, triangular, and we'd put numbers in here. It takes us 3 to 5 minutes. So we watch our units to put more film in the X-ray machine and get it going again. Now we'll run the model. Let's set it up. Now we give the project a name, like demo. That's a good one for today. And replication parameters, just one. In real work, you run a model, multiple replications. The replication length will be 8 with no warm-up. That warm-up is an interesting topic for another time, another webinar. We'll run it for 0 hours warm-up and 8 hours, and click OK. And then we'll click Go, and we have an undefined failure, failure 1. Well, how would we fix that? Let's look at our process. We would have to change the name of the failure. See, I called it more, in fact, I meant to type more film here. I called it more file, and we must not have spaces. So we'll go back to our resource. That's where the error appeared. This gives you an idea of where and how you debug models in Arena. All very realistic. And now our model is running. It's run to completion. You saw a little very basic animation. Didn't run for long. Yes, let's look at the results. And we served this many patients in 8 hours, and we can look at a report for the entities, for the processes, for the queues. Did a queue build up at the X-ray machine? There's a little queue there. For the resources, that was our X-ray machine. And in more advanced work, we can get even more detailed reports that are customized, because in Arena it's very routine to decide, well, I need a custom report. An example of that might be, well, in our queues we see things like the very standard key performance metrics that we can get with further detail here, such as average waiting time, maximum waiting time. It takes a little more work, not much, to get a key performance indicator like what percentage of patients or customers at the hotel registration desk have to wait more than 5 minutes. Is that 10% or 30% or 50% of all the people checking into the hotel? So I'll minimize Arena for now, and we'll go back to our PowerPoint. And so you've seen the demonstration, and there's the current version number in case of interest of this software. New versions typically come out every 6 months to a year. Well, how do you start the first project? Where would you begin? For this slide, I'll assume you're new to simulation. Select an area to investigate. Now, very likely the area in which the need for improvement is biggest is very conspicuous and pressing. There's complaints, there's obvious bottlenecks, and so forth. Now, preferably, your first model and your first project is small. You begin, for example, by simulating one production line, not the whole factory. Or begin by simulating the emergency department, not the whole hospital. Or begin by simulating operations in one portion of the warehouse, not the whole warehouse. And have a set of questions ready for the model and its analysis to answer. Now, I casually just gave one. What percentage of patients need to wait more than 5 minutes? That's a question with numerical answers, and preferably questions will be of that form. Will a new configuration of a production line permit reducing buffer capacities, there's your maximum queue lengths, from 20 to 15? Will a new piece of equipment for the X-ray room, plus one more part-time staffer, reduce the average waiting time of doctors and patients for X-ray results by 20%? Now, the model has to run on its data. Well, you saw me just put pretend data in the demo to get it going so you could see a little tiny arena model and its animation and its results. So the data must be available. They might be already collected. That's a nice situation. Or they can be collected. Or if it's a new system that's still on the back of an envelope, at least estimated. Now, who will do the project? And one common pattern is we do project one while the client watches and learns. The client does project two while we watch and coach, and the client does subsequent projects while we're on standby for questions. That's a common pattern. And when properly documented, a model can have a very long shelf life. Of all the models I've built in 35 years of doing this work, and there have been many, the longest shelf life I've seen so far for a model was 11 years. It came back to life and was used to evaluate new developments and suggestions 11 years after I first developed it. Now, after those questions are answered, then it's time to design the model, and only then is it time to roll out the software, whatever software may be in use, and you've just seen a good one.